Welcome to what is the area problem? It's really a huge problem in calculus, okay? You're going to see it a lot in calculus, so you're going to be happy that you're getting a good intro of it in pre-cal. This is exactly your final lesson for pre-cal, the area problem. Dun, dun, dun. Before I go any further, I want to ask you just a simple question. If you were to estimate the area of this region, which is this, let's say a parabola, okay, bounded by x-axis and this parabola, so this green region here that you see, this shaded part right here, this green region, what would you estimate it to be? Do you think it's -2, 1, 4, 6, or 9? Okay, so take a guess. Okay, what do you think? Of course, you can use some elimination, right? You can use some elimination. What other techniques can you use? Okay, so you're right. This is not a circle. This is not a polygon that you normally know, right? The actual formula to. So you're going to have to do something cool, like calculus, okay? And that's what we're going to do today. We're going to be able to find the area, or estimate an area at least, of a region bounded by certain functions and restrictions, and try to estimate as best we can. So here we go. All right, okay, so you can take a guess, right? We're going to come back to this later, skaters, okay? Hopefully no one said -2, and hopefully no one said 1, okay? All right, so let's come back to this. Let's go back to here now, okay? Part 1 is summation. Now, do you remember the summation in the sigma notation? We're going to use that, okay? Do you remember how to find the sum of 1 through 100, or 1 to 100, or 1 to 200 even? Yeah, you remember that, right? So you remember that it's going to be what? You add the first and the last term, right? And it's a preceding term. And you remember that the sum is going to be what? Half of the first and the last term added together. Remember that? Okay, I hope you guys remember that. So it's n here, and then I equals 1 all the way to whatever you have, right? So it's basically an S of n here, okay? Remember all this, I hope, okay? Now, so that means your sum is all your terms of your series added together, right? Of your sequence. The series is series is all the terms in each of that sequence added together, right? Okay. This is what is this guy right here? He's going to be in sigma notation, right? I through 1, and you have your first term. This is a geometric sequence, right? So it's I minus 1 up here. Do you remember this, guys? I hope so. But if it goes on infinitely, do you remember what happens to this guy right here? You remember? Yeah, it goes to 0, right? So it goes 1 minus r, and that's for infinite, okay? This is going to be for your infinite. So we know it's this, but we know that if your r is less than 1, it's going to be an infinite series. So it adds, the summation of that is going to converge to this value here. So all these things you're going to have to kind of remember, okay? You'll see how we utilize it later. Now, I'm going to give you guys some summation formulas and properties. And I know you know these already. Try to not be afraid of these summation notations, but try to think about what it's saying. This is saying, right, C is like just a constant. Like, let's say percent 5. But we have, let's say, up to 5. What's 5 plus 5 plus 5 plus 5? So how do we do that quickly? Exactly. It's your basic multiplication. So this is going to be your C times N. Your constant times the number of times that you want to add your constant. So for example, if you have 3 here, I equals 1, and you have a constant of 3, that means 3 plus 3 plus 3, right? That's what that is, okay? That means 3 times 3 in this case, which is 9, okay? All right, let's go here. This means you start with 1, next one you go to 2, next integer is 3, and you add up to however many n's you want. So hopefully you see that as this right here, which means it's going to be n times n plus 1 over 2. Same shape as this, okay? Okay, now let's go here. Now these ones, you're going to use it so much that you're going to automatically remember them, okay? So it's going to happen organically. So here, if you add 1 squared plus 2 squared, 3 squared, 4 squared, 5 squared, all the way to n squared, what do you get? You'll get something like this. All over 6, okay? How about n(i) cubed? Okay, I'm going to give you guys the formulas, but I think we kind of remember that we proved all this during our induction section, okay? So write these formulas down and you're going to utilize them later. And I have some basic properties for you here. If you have the summation of I to n of a sub I plus or minus b sub I, you can separate them. Okay, I'm just giving you some rules here that you can use. Plus or minus sigma of summation of 1 to n of b sub I. Another, so you can separate them. How about here? This k is a constant. Okay? So we can actually pull that k out and just take the summation of a sub I. Okay? Now, do we have to memorize these? Well, you'll see how naturally it will just happen. Okay? As we're working on this, please have your homework sheet out because you're going to do some with me as you learn. Okay? All right. Let's move on to the next section. Let's try an example, actually. Let's do an example. Okay? Woo! So let's see what this is trying to tell us. Okay? They're saying that we're going to go from 1 to n, okay? And we have this series. And it's basically 3, you plug in, what do you plug in? But it's only I. I is the only constant. So really I is your only variable. This is just a constant. Okay, I want you to remember that, okay? Because this is just saying that I is being replaced with 1. So it's going to be 3 over n cubed times 1 plus 1 squared. Next term is going to be 3 over n cubed, 1 plus 2 squared. So the I is the only variable. I, only variable. Okay, you gotta remember that, okay, as you work through this, okay? They want us to do something like this. So if they want you to go from I is 1 all the way to n equals, let's say, 5 terms. That means n is 5 here, and your I gets replaced here. Now, they want us to find a formula. Rewrite this sum as a rational function s of n. What does that mean? This right here, this is a magical formula that when you plug in any value of n, it's going to give you the sum. Okay? Hopefully that'll seep in a little bit. That means if I have a 3 here, and I plug in a 3 here, if I rewrite this as a rational function, this whole thing, it's going to give me the value when s of 3. Of course, this is just a example. If I want this right here, this series has 3 terms. 1, 2, 4, 3. And if we add them, we should get this magical formula will give us the sum. That's what we're trying to go for, okay? Now they're going to say use s of n to complete the table. So we're going to complete this table and c to find the limit as n approaches infinity of s of n, okay? Because this is an infinite series eventually, okay? So I know this seems a little bit like what the factor, but we're going to go through it, okay? So let's do part A first. Part A says, rewrite the sum as a rational function. So our goal is to eventually get to here and find this magical formula that will calculate the sum of all this depending on whatever you set your n to. Now, so let's look at this right here. But you know, you guys, I told you that this part was a constant, right? This part is a constant. So I don't care about constants because they stay constant. So I'm going to pull that sucker out and I'm going to have the summation only with what I care about, which is I. Only I is your variable, okay? N is your counter. Okay, so let's look at this. I told you, we talked about the properties earlier, right? I feel like it's going to be easier if we separate these. It's your A sub I and your B sub I, okay? So I'm going to separate this into 2 different summations. 1 plus I equals 1 to n of I squared. All right, we're rolling, okay? Now, we know, we're trying to simplify this, okay? Leave that constant alone. This is a constant summation, right? So let's use the formulas that we just showed you. 1, 1, plus 1, plus 1, plus 1, plus 1. How many times? N times. We don't know how many times, but it's n times. So what do? It's going to be n times 1. So it's 1 times n. Because remember, our general formula was c, a constant c times n. So in our case, it's 1 times n. Okay? Plus I squared. What was the formula for I squared, you guys? I squared was this, right? N plus 1, 2n plus 1, all over 6. Okay? This whole thing, when I add it n times, it's going to become this. We already know that. And you proved it during your induction section, okay? Now let's simplify everything. 3n cubed, and you get n here, right? Plus, I'm going to multiply all this guy in, okay? So 2n cubed, put 3n squared, plus n all over 6. Woo! Like told you, a lot of algebra here, okay? Make sure you verify my answer here. Now, here's the part where you're going to ask, when do I stop? It doesn't really matter until you can find the limit. So if you told me this is your answer, well, I'm going to like it, but maybe you can do better. So let's try it a little bit better. So n squared, okay? It's going to be the same. I'm going to simplify everything, and I make it something like this, 6n squared plus 9n plus 3 all over 6n squared, because I multiplied everything in, and I canceled out some n's. Or maybe some of you guys are going to leave it like this, 3n squared plus 2n squared plus 3n plus 1 over 2n squared. I don't know. It doesn't really matter is my goal, because you can look at this, and this is a formula. So going back to this summation here, if I say 5 here, I want this to be 5-term series. I'm going to put a 5 in here, and it'll magically calculate what the sum is. Okay? So I could actually leave it here. Let's leave it here. Ms. Chang will take this answer or this answer. It doesn't matter, because later, right? Here's what we're going to do. You know what? I think it'll make more sense if we do C. Let's do part C first. Let's take the limit of n approaching infinity. That's what they asked us to do. Of your S sub n. They want us to take the limit as n approaches infinity, right? So what do we do? Look, you guys. That means they want us to find the limit as n approaches infinity of 3n squared plus 2n squared plus 3n plus 1 all over 2n squared. And you know how to do that. How do you do that? Let's do this. You guys, 3 over n squared, you're right, it approaches 0. Okay? And you remember this part here too? How do you find the limit as n approaches infinity? You're right. All this goes to just 1, because you can divide this by n squared, n squared, n squared, n squared. And this goes to 0, this goes to 0. Okay? And you're left with 2 over 2, therefore the limit is 0 plus 1 or just 1. So the limit of S sub n as n approaches infinity is 1. That's the limit. So even if we add this n times, it's going to eventually reach 1 at max. Okay? So now, let's actually complete the table. Now, you know how to complete the table, right? So just plug in 0 into this formula. Okay? What do you get? I get 6. Plug in 1 into this formula. What do you get? I get 1.185. What do you get when you add 10 squared? You get 1.0154. Why am I adding these big numbers? Because n is going to infinity. N is going to infinity. So n is going to infinity, and 10 cubed is a pretty big number, right? Next one is 1.0015. And you can see that it's actually approaching 0 all the way to 1. That's what we're trying to find here, okay? So no matter how many we add here, we know eventually this series will, the limit as n approaches infinity will be just 1, okay? Okay, so let's try one more together, and we'll do it a little bit slowly. Now, if you feel confident right now, you can actually go ahead and try, number 11 on the homework sheet that I just gave you, okay? But we're going to try this one together. We'll try to get through it as fast as possible, but these take a while to do, okay? I'm just going to warn you. All right, now, find the limit of a summation. Find the limit of, basically what they're asking you to do is find the sum of S of n as n approaches infinity. Again, it's a series here, right? And think about it, guys. Don't be so scared of all this. Think about what is the variable and what is the constant, okay? So let's look here. Okay, here. So we're going to go. Already, you see, this is a constant. So we're going to pull that sucker out. Because remember, we're trying to find this magical formula S sub n, okay? And later, we're going to find the limit as n approaches infinity, okay? Now, S sub n, so we're going to go like this. And we're going to pull out the constant. And what are you left with? You're left with sigma I equals 1 to n. And you have this right here. I'm going to multiply it out. So this is a constant, so I pull that out. This multiply. So I get 1 plus 2ni, right? 2ni plus I squared. But I know that there's an n on the bottom, so I'm going to go n squared here. Now, if you didn't understand how I did that, just go ahead and multiply on the side this. And that's what I got, okay? Now, I'm going to work with this sucker here. Well, wait a minute. Isn't this also a constant? This is also a constant. So I'm going to pull that out too. So I get cubed here. And I'm left with sigma I equals 1 to n of 1 plus 2ni plus I squared. Ding, 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 ding. I know you already see it. You're like, oh, I can separate these three parts. This is a constant, this is a linear, this is a quadratic. And you know the formulas for all of these. Exactly. So let's leave the n cubed outside, and let's actually calculate these separately. So I equals 1. I'll write this. N to I equals 1 all the way to 2ni. But wait, you can pull the 2n out too. So if you don't like that written like that, just pull out that 2n and leave it outside. Plus, okay, I squared and n, I equals 1. Sorry about that, sigma sign, I equals 1. All right, so we have three different sigmas to actually simplify, okay? Summations. This guy is just going to become n1 again, because it's Cn. It's a constant being added n times. Here, it's going to become 2n. And what's your I? You know the formula already, right? It's n plus 1 squared, right? Plus I squared, the formula is n plus 1, 2n plus 1 all over 6. We're just utilizing our formulas, right? Now, I'm not going to do every calculation here, but I'm going to trust you that you're going to calculate this and simplify this as much as you can, and see if you can get to here. 14n cubed plus 9n squared plus n over 6n cubed. That's a good one. That's your S sub n. This magical formula, for any number of terms you have in this series, will give you the sum. Okay? Now, if we were taking the limit as n approaches infinity using this S sub n, right? What would we get? We would get this. Limit as n approaches infinity. Now, just do this just enough so you can actually find the limit easily. So you don't have to go as far as even I did. You can even go stop in the mid-range, as long as you can find the limit easily. So what I would do is 14n cubed plus 9n squared plus n all over 6n cubed. What are you going to divide by? The highest power term of your denominator. N cubed, n cubed, n cubed, n cubed. And you know what you get? You get 14 over 6, which is 7 over 3. So, in conclusion, it's about 2.3333. This limit, even if you keep on adding all the terms forever, infinitely, it's going to approach 7 over 3. That's what this is saying. You're taking the limit. Now, I want you to stop and try number 11 on your homework. It's this problem here. It's on the sheet that I gave you, okay? Good luck!